Imagine a cancer that doesn't just arise in one animal, but actually spreads between them, like a parasite. That's our opening question today. And the answer came from a lake, a catfish, and a set of matching tumor genomes. Welcome to episode 3 of Science Week, the science of the week for July 28.
That one caught my eye too. It's the kind of story that makes you pause and say, wait, cancers can do that? Some can, and now there's a new example in freshwater fish.
We'll start there, then visit a 240 million-year-old giant amphibian being restored with the help of thousands of volunteers. A safe landing from orbit after 241 days. A nuclear-powered rotorcraft headed to a distant moon. Galaxies that grew up faster than models expected. 2 stellar explosions that look like twins. And what simulations say about how the mass of a star sets the water budget of the rocks that build planets.
A good arc from life in a lake to the structure of the universe. And as always, we'll keep it grounded. What the data show, what's still to come, and where the hype needs a seatbelt.
A responsibly buckled seatbelt. Let's start with the fish, because that's the twist no one expects on a summer lake day. Scientists at the University of Vermont, led by Julie Dragon, reported that melanoma tumors in brown bullhead catfish from Lake Memphremagog share a common genetic lineage. Yahoo reported the announcement on July 22. The researchers said that shared origin indicates the cancer may spread between fish, potentially the first known transmissible cancer in freshwater catfish.
The key phrase is share a common genetic lineage. In plain terms, when they looked at the tumor genomes, they didn't look like independent tumors that separately mutated. They looked like copies of one ancestral tumor line, which is a hallmark of a transmissible cancer. That's the logic.
Which is wild. A tumor acting more like a contagious clone than a personal accident. And it matters because it adds a new chapter to the handful of transmissible cancers we've heard about in other animals. And it raises questions about ecosystems and disease dynamics in freshwater environments.
A few cautions. Based on the reporting, this is an announcement. We don't have details like sample size, exact methods, or a published data set here. The wording says, indicates the cancer may spread between fish, which is appropriately careful. It's not a controlled transmission experiment, it's a genetic inference. Good evidence, but still early.
So the takeaway is not fish are contagious now. It's in this lake, these catfish melanomas look like they come from a single source. That's both specific and surprising.
Exactly. Also, nothing here suggests any risk to people or to other species beyond these fish. The study is about brown bullhead catfish in one lake, and we don't know the route of spread, whether through physical contact, injury, or something else. Those are open questions.
Still, the concept itself rewires how you think about disease. If the environment and the hosts can facilitate this kind of clonal spread, that's a very different management problem than, say, preventing exposure to a chemical. You'd want to trace the lineage and the conditions that let it hop.
And you'd want independent confirmation. More sequencing, more lakes, and ideally a clear mechanism. For now, it's a provocative, carefully framed finding. Shared tumor ancestry in fish that points to transmissibility. That's worth attention and restraint.
Science at its best. Surprising and bounded by what the data actually say. From a living lake to deep time, Polish scientists at the Copernicus Science Center in Warsaw have begun cleaning a near-complete Mastodontosaurus skeleton discovered in southern Poland, preparing it for display. AP reported that this 240 million-year-old amphibian fossil is exceptionally well preserved for its age, and thousands of volunteers are helping restore it.
Near complete and exceptionally well preserved is rare language in paleontology. Bones that old have had a long journey, so the preservation and completeness here are the headlines.
There's something lovely about bringing a giant amphibian back into view with that many hands on deck. It's not just a lab behind closed doors. It's scientists and thousands of volunteers. Public science, literally in public.
It's also respectful to note what we don't know from this report. No measurements, no specific locality beyond southern Poland, no scientific paper yet. This is a museum-scale restoration effort that will culminate in a display, and the news is about that process kicking off.
And it's good news. a tangible piece of Earth's past coming into focus. When it goes on display, it's going to anchor a lot of conversations about what life looked like before dinosaurs were the main act.
And it's a reminder that discovery isn't just the moment of finding a fossil. It's the careful cleaning, assembly, and context building that follow. That's the science work, too.
Plus, the patience. If it takes a village to raise a child, it takes a city to raise a Mastodontosaurus. Back to the present, but still with a touch of drama. A NASA astronaut and 2 Russian cosmonauts landed safely in Kazakhstan on July 26th after a 241-day stay aboard the International Space Station. NASA's Chris Williams and Russia's Sergei Kudzsverchkov and Sergei Mikheyev touched down in the steppe near the town of Zhezkazgan, riding home in a Soyuz capsule.
A safe landing after 241 days is a good sentence. The Soyuz system is designed for this kind of return. A high-speed re-entry, then descent and touchdown on land. And the location, the Kazakh steppe near Zhezkazgan, is standard recovery terrain.
I also hear the quieter note there. International crews doing very practical, very human work together for months at a time, and coming home safely.
As always, the details we have are limited to the who, where, and how long. We don't have a mission science summary here, or their specific experiments. But the milestone stands. Nearly 8 months aloft and a nominal landing. That's routine by design, which is exactly how you want spaceflight to be.
Routine, but still a small miracle each time. Gravity is patient, we should be too. Speaking of flight, NASA is set to launch a 1,000-pound nuclear-powered rotorcraft, the Dragonfly mission, to Saturn's moon Titan. According to reporting from 1945, the agency has approved the mission, with a budget at $3.35 billion and a 6-year span. The launch is planned from Washington, D.C.
A rotorcraft is essentially a flying craft with rotating blades. The detail that it's nuclear-powered is key. That power source supports operations far from the sun. The budget and 6-year scope give a sense of the mission's ambition.
And approved is a big step. It moves a concept from the dream board to the build board. I like that this isn't just another orbiter. It's a vehicle designed to fly, land, and fly again.
A couple of caveats. The report notes approval, a budget number, and a mission duration. It doesn't give a specific launch date, just that the launch is planned. Big missions often see schedule adjustments, so it's fair to say set to launch, and also fair to expect the calendar to be a living document.
Space schedules, like soufflés, rise when they're ready. Still, Dragonfly's shape, a rotorcraft, makes it feel different. You can picture motion, exploration, hopping from place to place.
Within the facts we have, that's the right image. A rotorcraft mission powered to operate at great distance with a multi-year plan. The interesting science questions will come into focus as more technical details are shared. For now, the approval and scope are the news.
The James Webb Space Telescope keeps nudging the story of the universe. And this week, it's about how quickly the earliest galaxies formed stars. Listverse reported that Webb, along with Hubble and other observatories, captured data that's reshaping how scientists think about galaxy and planetary system formation. Those observations suggest revisions to models of galaxy evolution. Early galaxies formed stars faster than expected.
The phrasing, suggest revisions, is important. It means that the observations, across telescopes, are inconsistent with some prior model assumptions, especially around star formation rates in the early universe. That's a common pattern. New data, same physics, different parameter values.
It's like taxing your imagination. If the universe got busy sooner, the scaffolding for planets might have come together in a different rhythm.
And this is where we separate signal from noise. The report doesn't cite a specific study or a quantified discrepancy, so we don't have, say, twice as fast or in such and such epoch. Without those numbers, we treat it as a qualitative update. Early star formation appears more vigorous than some models predicted.
Still a big deal, though, because models aren't just pretty curves. There are forecasts for structure and history.
Exactly. And with Webb, the data quality is high, but still subject to interpretation. Calibration issues, selection effects, and the challenge of seeing very faint, very distant galaxies.
The cautious stance is that models will be updated, not overturned.
The universe remains intact, with slight edits, copy edits from a new instrument. Staying with the cosmos, but zooming in on a spectacular remnant, astronomers have confirmed twin supernova remnants from a binary star pair. International researchers led by Miltiadis Michaelides reported that the Jellyfish Nebula, IC443, and the neighboring remnant, G189.6 plus 3.3, both in the Gemini constellation, likely originated from a massive binary star system. The idea was first floated in a phys.org brief that linked the two remnants.
Two remnants in proximity, with characteristics that suggest a family connection. That's the essence. Likely originated acknowledges that we don't watch stars die in real time. We infer the past from the shapes, motions, and spectra we observe now.
The image in my head is two massive stars living together, and at the end, leaving behind two expanding scars in the same patch of sky.
The Jellyfish Nebula is a well-known remnant, and pairing it with G189.6 plus 3.3 as a binary outcome helps explain why they're neighbors with compatible ages and properties. The team attribution is also clear, an international group with Michaelides named as lead.
What I like is that it's a story about origins in pairs. So much of the universe is social. Stars in binaries, galaxies in clusters, even endings can be shared.
And the confirmation here is a consolidation of prior hints. The report doesn't dive into the methods, no new instrument specifics, no time baselines, but the conclusion is tidy. Two blast marks from two related stars.
Celestial twins with matching tattoos. One more on how planets come to be. Researchers reported, using simulations run with the James Webb Space Telescope, that planetesimal formation tends to occur during the stable disk phase for all stellar masses. The study found that low-mass M-dwarf disks lack early formation, leading to planetesimals that are largely dry. By contrast, disks around higher-mass stars see earlier formation, which yields more water-rich planetesimals.
Let's unpack that a bit. Planetesimals are the small building blocks that later assemble into planets. A stable disk phase means a quieter, settled period in the disk of gas and dust around a young star. The key result is a comparative one. Around low-mass stars, M-dwarfs, the formation happens later and drier. Around higher-mass stars, earlier and wetter.
Which is a neat, intuitive lever. Star mass sets a clock and a water budget for the rocks that will become worlds.
But it's a simulation study. The report explicitly says using simulations run with the James Webb Space Telescope, which is a slightly unusual phrasing. But either way, we're talking about modeled physics informed by constraints, not direct counts of planetesimals. Simulations are powerful, and they're also hypotheses you can test with observations.
So if you're dreaming of water-rich building blocks, you'd look to the higher-mass star neighborhoods and be more cautious about the dwarf star suburbs.
With the reminder that largely dry and more water-rich are relative terms here, not a percentage we can quote from this report. We also don't have a sample of observed systems to validate it yet, at least not in this summary. It's an organizing idea that helps frame expectations.
And that's valuable, even the framing. It tells observers what to look for and where a telescope's precious hours might best test the theory. If there's a thread running through the week, it's that nature loves to break our neat boxes. A cancer can be contagious in a fish, maybe. A fossil amphibian can survive almost whole for 240 million years and then meet thousands of museum goers before it even stands up. A mission can trade on wings instead of wheels. Galaxies can grow up faster than our tidy curves. Two stars can share an ending. And a star's mass can quietly set the recipe for the worlds to come.
And in each case, the tone matters. The fish result is an early genetic signpost. Transmission is inferred, not observed in a lab pass-along. The fossil story is an exhibit in progress, not a new species paper. The landing is a safe, routine success, not a new technology demonstration. Dragonfly is approved with a budget and a plan, not yet on a launch pad. The Galaxy result is a model update prompt, not a revolution. The twin remnants are a likely family portrait, not a time machine replay. And the planetesimal work is a simulation-driven hypothesis, not a measurement of rocks around specific stars.
Which is exactly why I love weeks like this. You can feel the scaffolding growing. Methods, missions, models, while people do the quiet, careful work of turning surprises into understanding.
And occasionally into a museum display taller than a house. Probably a good day to thank your local volunteer fossil cleaner.
And your local sample size respecting astrophysicist. Balance is everything. That's our tour for this week. If you want calm, checked science news all week long, come find us at factslane.com and in the apps, App Store and Google Play. It's the same measured tone you hear here.
And if you like a broader view, check out the sister shows, Good Week for a clear-eyed look at the news, and Tech Week for what's new in computing and gadgets, minus the drama.
Thanks for listening. We'll be back with another lap around the lab and the cosmos soon. Until then, stay curious.
Take care, and see you next week.